Yeah. So, we touched on some of this, and I'll show a little bit of the same material today. But it was obvious, what I would think the major concern of most people in the later stages in their life is cognitive function, in a spouse or in themselves or both. And because that's what scares us, kind of losing control, no longer capable of looking after ourselves, in a system that increasingly is dysfunctional about handling people. And who have those needs. Maybe we're living beyond what we should be living beyond. I mean, let's face it, when I was in medical school, so maybe a little bit will fit in with this, but people, I can't remember, well, before medical school, I can't remember people on my block who were in their 80s. And I certainly don't remember anyone in their 90s. There is no equivalent to St. Mark's Church in my home. I mean, people actually looked young in church. Or at least there was a spectrum. We didn't have this tail, this long tail of white heads and that kind of thing. And also, just mentioned Virginia, and that, there have been, in the 22 years I've been at St. Mark's, I think there have been 4 photo albums. And I hold them all out kind of a couple of weeks ago. They're renewed about every several years, often after rectors changed. And there's a cliff. People, and I realized, holy mackerel, that person died, and that person, and that person. I mean, all the people that I remember in the first decade of being here are gone. And so those are reminders of, and if you're moving around in the middle part of your life and moving from place to place, you don't keep track of this stuff except in your family, and you don't see the big picture. But certainly the big picture's on display in a community like this, or at least in a part of this community. Well, anyway, let's get into this. Here was an interesting article that a good friend of mine in London, Peter Castle, the engineer, sent along to me, and but written by Sharon Cohen, and it got in the Globe and Mail on 21st of September, so it's pretty fresh. And she's the director of the Toronto Memory Program. It's a big program in Toronto. And in that article, she says the current figures suggest that almost 500,000 Canadians live with dementia now. Well, if that's 500,000 labeled as dementia, double that for those on their way to being labeled. And the number is expected to double by 2030 and reach, 1.5 to 2 million by the mid-century. That's a pretty approximate thing. I directly quote what she says here because I take issue with some of the latter part. This is a large clinic. She and her clinic and colleagues are promoting some of the new monoclonal antibody drugs for the treatment of Alzheimer's disease, like almost every other major dementia center in North America and Europe and the UK are doing. And so they see a lot of people with this, but also they have a vested interest. They get a fair bit of money from these clinical trials. I don't mean salaries, but in supporting staff and programs and research programs. So I have to say there's a vested interest in this stuff. And this has really come through in spades, and you'll see this later in this session. But as she says, in the early stages, the symptoms are often conflated with normal aging. Well, we just talked about this, several of us talked about that. Well, when is this become a disease, and when is it part of normal biological aging? Well, I happen to think it's mostly biological aging labeled as a disease. It doesn't make any difference as far as the pathology goes and the outcome, and nor does it change how we might treat it, except that it does as I mentioned a couple of minutes ago, the last 4 sessions, if they've driven any point home, it's that cells, as we get older, fail in almost every single cell system. It isn't just mitochondria. It isn't just kind of protein. It isn't just the DNA. It isn't mRNA. I mean, it's all of the above and everything else, including the garbage collection and disposal systems. They're all failing. It's like us. We don't run as fast, walk as fast as we used to. We're not as nimble as in our thinking and that kind of thing. It's all systems are not necessarily in sync and to the same extent at certain times, but all systems are going. That's very typical of something that's a natural biological phenomenon. Notice I didn't call it normal. Okay, it's the way it is for every species that we know about, from a single cell to a complex, highly social species. Where I take issue with her is, it says is a passionate, I'll underline that word passionate, that means somebody with a cause, passionate advocate of early Canadian approval of lecanemab, which in her view, the words are important here, buys precious time at the early stage of the disease, the implication being Canada's been slow to adopt this, which has been approved in the United States. We should get going and hopping on this stuff. When time is most valued and reduces the risk, this is a huge claim, and it's just not there in the clinical trials, and reduces the risk of the disease progressing to more disabling, costly, and distressing. It does not. None of these trials have shown that. None of them have gone beyond a year and a half or 2 years. That's a statement that just there's no evidence for. And even if you did slow the progress of the disease, you're kind of putting it off. It isn't as if you're stopping it. It isn't as if you're taking out an inflamed gallbladder, and that's the end of the issue. The basic underlying biological changes continue to take place. To follow what I'm saying, this is really important because it influences how expectations about drugs. Just to delay something. I mean, there are a fair number of people in our age group who have one or other form of cancer that are on a certain cancer drug, often a monoclonal antibody, and they can live with their cancer. Right? We're familiar with some people like this in the community. They've been motoring on for a decade or so, getting their monthly infusion or every six weekly infusion and kind of checkups and that kind of thing. So kind of putting things off and off and off. And they are gaining useful time. But that's not what's been shown here by any study. So, and given how expensive these things are, anyway, I don't want to get into the details of all this, but there are a lot of these neurodegenerative diseases, and but in order of frequency, Alzheimer's is certainly at the top, Lewy body dementia next, and frontotemporal degeneration third. Parkinson's disease is actually quite common. And these other things are fairly uncommon. This is related to sports, the concussion encephalopathy. Anyway, there's a lot of variety in this, and when I go to Pleasant Manor, I can see several varieties of these on show, so to speak. And sometimes things like Alzheimer's disease really behave unexpectedly. This, this has come from another case, but I had a lady like this who was a very clever and mathematician and economist and excellent social company, a crisp mind. And then very gradually she noticed, boy, it was increasingly difficult in social situations because she could think quickly, but she couldn't find the words to express herself. And it's so intimidating to her over kind of a year or two that she kind of didn't want to go for fear of embarrassing herself. And she eventually lost almost all language output, and you can see why, because, by the way, on all of these scans, left is on your right. So this is the speech area, And this is 4 years, I think, between this, 61, 65.
Oh.
In 4 years, gone from an abnormal scan, right, you can see right in the speech area, the temporal lobe, all the shrinkage here, the gingival atrophy and that kind of thing, but no ventricular enlargement, and which is all good. But look at it over there. Wow, quite a change. And of course, it isn't just in the speech area here. And by the way, it's spread because the ventricles are starting to get larger, but it's now in the frontal lobes. So 4 years later, yes, Elizabeth?
Sorry, wait, was that, why that whole blank? Was that vascular insufficiency?
No. This is one of the variants of Alzheimer's disease.
Oh, okay.
That's a very local one, an aphasic, so-called aphasic form of
And that was
Alzheimer's.
caused by the
Well, that's
cell-
what happened.
the cells?
You would see amyloid
Yeah.
and tau.
Not
the
vascular.
pathology. No, not vascular.
Okay.
Yeah, this is not a stroke.
Mhm.
Behaves like a stroke
Yeah.
in the nature, but not in the insidious progression of the thing. That's not a stroke phenomenon.
Okay.
So, going on, trying to set a stage here. Now, this deals with non-degenerative causes, and strokes are a big part of it. My sister had 6 lacunes, the little holes at the base of her brain, and no symptoms to match for her. It's very common to have these little spaces, gaps, at the base of the brain. She had 6 of them. And I kind of went over her story with her a couple of times, looking for some correlate, and there wasn't any. And a lot of the times they are asymptomatic. Single large strokes are devastating. And of course, this brought in, as you know, endovascular treatments and getting the embolus out in a timely time, which preferably is under 6 hours. But you can still do it with some success up to 12 hours. So one large branch, and sometimes strategically located single strokes. My father-in-law had this, and he had a little stroke affecting the dorsal medial nucleus of the thalamus. I'll show you a little picture, not him, but somebody like that. And he lost the ability to make new memories for about 72 hours. And then he recovered that. And so sometimes strokes really hit an exquisite area of the brain, so the stroke actually may be very, very small, but the symptoms are profound for the time. And of course, this is an issue. Arrhythmias of the heart are very common, especially atrial fibrillation. That's associated with a greatly increased risk of stroke, which is why people get on anticoagulants. You have the perfect setup for a spontaneous bleed, or a little bleed in response to a minor trauma, a little bump in the head, or often in this case, they can't remember that. And I have another friend whose husband had this, and then over several weeks became more quieter and quieter, and then eventually she had trouble waking him, and had a big clot, subdural clot that could be taken out, and he recovered quite well after that. So drug-related, this is very, very, very common because people in our age group get on sleeping pills, sedatives, they get on anti-anxiety medication, they get on a whole slew of medications that might be well tolerated in midlife or younger, but in the later years, the brain doesn't buffer those things, doesn't metabolize those drugs that were tolerated well earlier. This is why cleaning out the drugs in nursing homes is so important when people come in and they're on a list of these things. You have to take them off, the stuff, and often if you clean that stuff out, the patient gets significantly better, at least for a time. Normal pressure hydrocephalus, I put this in because this was discovered when I was a trainee in Boston, but I'll just tell you a case of a fellow who was the head of a large legal firm in Boston, and so he had colleagues, and they all kind of worked for him, and he got the highlighter clients, the ones that had a lot of money to spare. Anyway, But they increasingly became, a little unhappy with him, and he was making mistakes, and didn't show really good judgment. And then he started to shuffle his walking, started to shuffle. And sometimes he was incontinent, but people go, well, that's his prostate, it's his age, that kind of thing, but it wasn't. And they did a CAT scan, he had enormous ventricles. And normal pressure, that's why the title, normal pressure hydrocephalus. And no one knows what really causes it, but the great thing is it's so treatable. Because if you put a lumbar puncture needle in and drain off, 50 cc's of CSF or as much as you can get, miraculous changes take place in a matter of days, less than a week. Now they don't last because it comes back, so that's the diagnostic trial, repeated another time just to make sure that was the answer, and then put in a shunt. But if you don't think about stuff that's manageable or treatable, not everything is Alzheimer's disease. Okay, so you can't be dismissive about things. You do B12 deficiency, alcohol. This is happy hour town, and that's fine. It's not so fine in the later decades. I mean, alcohol is a toxin. I hate to say it is a toxin, and cumulatively it does damage nerve cells. I'm not saying that we should give up alcohol. I like it too much, but anyway, if you add that on to other stuff that's going on, it becomes a problem. If you're a high-functioning person to begin with, and you haven't lost much otherwise, fine, carry on. Anyway, so now, this is one of the issues here, because Alzheimer's disease, if you took all of dementias, what's the overall frequency? 50 to 70%. Well, why can't they put a precise number on it? Because it's hard to be sure sometimes, just based on the clinical picture or the imaging pictures. And vascular cause, meaning stroke. So these two coexist a lot of times. So so the patient may be labeled as Alzheimer's disease, but there's a component, there's a vascular component. And the vascular component you can do something about. You can prevent it. Most of it, because most of it's related to hypertension. And so managing the hypertension. So that's a really important thing. But to the extent that a third of this is related to vascular disease, that is not going to respond to a monoclonal antibody for Alzheimer's disease. Do you follow what I mean? So if somebody, it's probably the case that maybe at least a third, maybe a half of people with labeled Alzheimer's disease also have some component of vascular disease. So there are comorbidities of one another. The drug targets Alzheimer's disease. It doesn't do anything about the vascular component. So that may account for some of the failures of these drugs that are targeted on amyloid. Follow what I'm saying? So that's important. Because it doesn't come out in the appreciate. If you read the original papers on the trials, it doesn't say anything about it. In fact, I haven't seen one trial, and they've all gone in the New England Medical Journal, because that's where the pharmaceutical companies want it, because that's a high-profile journal for clinical trials, and that's where they want to be seen and validated. Almost nothing is done to look for this. Well, Lewy body and the rest of them are less common. Well, just show you, we've been talking about aging, and a couple of articles in the newspaper about dividing life into thirds. I don't mean crisply into thirds, but there is an early period to life, roughly up to the early 30s, mid-30s. There's a long mid-period, mid-30s, what I call the presidential time, up to kind of 60, 65, maybe 70 with a stretch, and then there's beyond. Well, if you want to see the cliff to the beyond, look at it. Here, this is the prevalence of cerebral small vessel disease. This is based on imaging, and in some cases, autopsy evidence. So this is hard evidence. So 50 to 70, well, infarcts, remember I told you my sister had 6 of these things, and that was in her 70s. And some white man, I mean, is there a normal MRI past the age of 50? I don't think so. The reports all come back with microvascular change in the report. That little ad in microvascular change is probably in 70 to 80% of MRIs past the age of 70. No one knows the significance except my good friend Vladimir Shinsky in London, who really pointed out that that stuff may be important. But look at the change here. That's why I put in the red dotted line here. At 70s, it kind of doubles or more, doesn't it? And so things are changing. Doesn't mean there are any symptoms related to this. Doesn't mean that anything happened, that there's a history of this happened or that happened. It means that a picture was taken and those are the findings we saw. Okay? Doesn't mean that there are any clinical correlates at this time, but it does tell you the pathology is beginning to pile up. So, and now here's microvascular change to, I mean, this is very late. Now the ventricles are quite large, but it's this white matter change around the ventricles that's often reported as microvascular change. This is late stage, I would think, with hypertension. Here's somebody who might have had what my father-in-law had, and I did love the guy. He was a great guy, but he had this he had a great sense of humor. There's the little infarct right in his dorsal medial nucleus of the thalamus that has been exquisitely associated with the inability to form new memories and retain them for a while, and that's exactly what he got down in Barbados, and for the next week or so. You could go in the room and talk to him, he's quite fluent, leave the room for 30 seconds or a minute, come back, completely forgotten that you were there. And, but then it recovered. So anyway, that's about that strategically located thing. Now I'm not going to go through all of these because there are differences. And obviously, if it's a different form of dementia than Alzheimer's disease, then these monoclonal antibodies targeting tau and beta amyloid aren't going to help. So you do have to try and figure out, is this Alzheimer's or is it Lewy body dementia? This is not common. It's kind of Parkinson's disease that you can't treat. It doesn't respond to Parkinson's drugs, and it fluctuates, clinically fluctuates, and these people hallucinate. They have visual hallucinations. So, but clinically, as far as their stiffness and woodenness and when they walk, it looks like Parkinson's disease. And frontotemporal degeneration, it really, these are often the one variant, because it attacks the frontal and temporal lobe, behavior is really affected. I mean, their cognitive, I mean, their mathematics, calculation, all that kind of thing may be fine, but very commonly they become impulsive, inappropriate, apathy. Oh, I could just keep going with the adjectives here. But anyway, this is frontotemporal degeneration, and look at this. Wow, look at this. It's like this person has the brain divided into two, the front half and the rear half. Because here's the rear half, the parietal and the occipital stuff in the brainstem. It's not normal, but it's pretty good. But look at how shrunken the gyri are in front, in the frontal lobe here, and a lot of the connections of that area with other areas of the brain have been lost, hence the increase in ventricular volume, the shrinkage of the brain, and therefore the increase in the ventricular size. And you can really see that with a horizontal slice, can't you? Because here, relatively normal sized lateral ventricles at the back, but look at the front ones. So the whole, both temporal lobes, especially on the left side, and the frontal lobes are all shrunken. So this is the part of the brain that the reasoning part of the brain, the planning part of the brain, the empathetic part of the brain, the one that correlates what kind of goes on with emotional aspects, makes that connection, if you like. And it's very striking here. And even though the New England Medical Center had 3 cases to illustrate this, it's still uncommon. I put this up for historical reasons because this is very uncommon, but John Steele was a chief resident when I went in the neurology program in Toronto, and the chief of neurology was Rick Richardson, kind of a very quiet guy. In those days, of course, anyone who wanted to learn neurology had to go to England. And specifically, they had to go to Queen Square in London, England. Or they might be a renegade and go to the US. And if they did, it would be to Johns Hopkins, not so much Harvard. And, but this is very striking because these people can't look up or down. Can you imagine trying to go downstairs if you can't look down? And if your balance is already impaired? So is it any surprise that these people are unsteady walking and have frequent falls, and if they're having falls, fractures, right? So I just put it up because I know the principal. I knew Rick quite well, not so much John, but he actually went out to the Far East. I don't know what happened. He went out there for about 20 years. And yeah, I'm not going to talk about this or that, or that. Well, what about identifying Alzheimer's disease in the preclinical phase? Because this is what's really important, isn't it? If you're going to treat, well, this is probably applicable to almost every disease, the earlier you get it, the better, easier to manage. The problem is these neurodegenerative diseases develop over a long time. Now, they're not the only diseases. So does vascular disease, so do the consequent strokes and that kind of thing. If somebody has a stroke at the age of 75, it didn't just happen at 75, particularly atherosclerosis or hypertension related, it's probably been going on for 2 or 3 decades. And then things got bad enough until one day, one vessel ruptured or became occluded, or an embolus plugged the vessel, and we think, oh, gee, how'd that happen? But it's been in process for a long time. So also with these neurodegenerative diseases. The evidence we have is if you take the starting point as the time when somebody labeled somebody in a memory clinic, or at least a Alzheimer or dementia clinic, as yes, you have it. You can roll it back, the story, for sure, almost 2 to 3 decades. And how do we know that? Because, and I found this out about with Jan. I mean, I lived with Jan and I knew her pretty well. I could track it back kind of initially, maybe 10 years, but then with the family and some friends, it actually went back much further, at least another decade or even more. And, but there's stuff that we just kind of wrote off, including the last day or the last year in Boston, and Jan always managed the financial stuff, and she had her father savvy with that kind of stuff, or at least she did. And then one day I noticed, my God, every horizontal surface in the kitchen and in the living room was covered with stuff. And I thought, well, what's happened? Is something really complex this year with our financial stuff? And I safely stayed away from it. But now I look back, and I think that was probably one of the things, and the odd times kind of missing appointments, which she would never do. I mean, Jan was cleverer than I was. but she started to lose stuff.
What
And-
age?
And she had a history. There are 4 people in her family, a cousin, 2 aunts, and another one. And and she was always worried that this might happen. Well, it did. So I would think, I mean, we've been in Normal 22 years, so I would think this probably started in 2005, 2006, 2007, something like that, the earliest part. And so I'm just mentioning that this stuff goes back a long way. You can image the brain with PET, positron emission tomography, targeting amyloid or tau, and you can certainly go back 1 or 2 decades, maybe sometimes a little bit more. But imagine there's a threshold for these diagnostic studies. There's probably a decade before that, before the test actually shows it. You follow what I'm saying? Okay. And genetic testing is helpful. Strong family history, well, I just mentioned that. There is this ApoE gene that no one seems to know what it actually does, except that if you carry 2 mutant copies of it, meaning 1 copy from each parent, 50% of the people with that will develop Alzheimer's disease. If you have 1 copy, a quarter will. If you don't have any copies, 10%. And if you have the Alzheimer's disease autosomal dominant gene, as there's a large extended family into the hundreds, even thousands now in Colombia, with autosomal dominant Alzheimer's disease. If you are positive of the gene, you are going to get it. And 100% are going to get it. And you're going to get it 1 or 2 decades before most the stuff that we see. And it looks just like our Alzheimer's disease. It's the perfect route for any trial of a drug, because you know exactly who's going to get it, who's at risk, and you can get on it early, well before things. So that's a perfect thing. Then there's little quirks from time to time. A group of Icelanders were found to possess. In fact, some of these had those ApoE4, so with a 50% risk, but because they had this mutant gene, it reduced the chances of Alzheimer's disease almost down to random. So that hasn't been worked out entirely, but look at this. Excellent cognition into their 90s, so maybe we should have been born in Iceland. And now, what is mild cognitive impairment? The reason why all of this is important is because the whole idea of treating Alzheimer's disease and these neurodegenerative diseases and vascular disease, I might add, a whole bunch of other things, is get it early and treat them ideally when they're only mildly affected, or even better, unaffected clinically. Get them early. If you can identify them 1 or 2 decades before that is the time to be treating. Now, we do this with hypertension, don't we? People don't have symptoms of hypertension. They go into a doctor's office and they have their blood pressure taken, and if the doctor's doing his job, and they check this several times a year, at least twice a year, they can see the trend. It is one of the most treatable risk factors around hypertension. So get on it, and easy to get on it. It's not so easy with Alzheimer's disease, but that same principle, getting on it early, holds true. All right. So mild to moderate memory impairment, otherwise okay. One of my colleagues in Boston invented this mini mental state, and I never thought it was a great test, but anyway. So here was a case vignette, 70-year-old lady. Now this could be us. Just read it. Notice the increasingly forgetfulness over the last 6 to 12 months. always had a little difficulty recalling names, and certainly me. She now finds it difficult to keep track of appointments when I'm not there yet. And recent telephone calls, I'm not there yet. Lives independently, drives the car, that's a risk. Pays her bills, that's important. But you want to know that she's actually doing it properly, not that she claims that she's doing it. Fraud is a big business in this community. And people in our age group are very susceptible, especially those with mild cognitive impairment. So, so there she was. Now, here's, I just want to show you this because here are 3 MRIs, and they're more or less through the same slice, going down through here, so the lateral ventricles. This is the person, a so-called normal person. Well, I can tell you it's not quite normal. Is it an MRI from somebody 30? No. It's already showing some change with some sulcal widening and this kind of stuff around here. Normally those things abut one another quite tightly in people in their teens and 20s. So the space is already opening. But from any other perspective, called normal. Here's somebody with mild cognitive impairment. Well, yes, it is perfectly true that this person has atrophy of the hippocampus, which is a key memory station in the brain, and more on the left side than on the right side. That's true, but that isn't all, is it? Look at the lateral ventricles. They're large, and this sulcus is wide open. And so there's a lot more happening to this brain structurally than in the history, right? And this is a person with Alzheimer's disease. Actually, when I look at this, there's not a lot of difference between this and this, except that there's more medial temporal lobe atrophy here in the hippocampus. That's true. The point is that this continuum, which really begins, if I had all the brains lined up here, started out at that person in their 20s, out in the 80s and 90s, you would see these slow transition changes. Okay. There wasn't a time when Alzheimer's began. There wasn't a calendar date, May of 1990 or 95 or something like that. It is a continuum. It's when symptoms rise to the level of a person's awareness or the people around are aware. Okay? And often people are reluctant to report them or don't want to think about that or fess up to stuff. Certainly not want to bring it up with the person for fear of upsetting them. And all kinds of things are in play here. But the point is there are pathological correlates. And they occur earlier, and this is very true with the PET scan here. This is beta amyloid, this is all abnormal. And at 3 kind of stages, I mean, this brain's literally on fire with beta amyloid. And so that's a lot of change. Now, this is an important one. Beyond memory, a lot of the focus is on memory. But it isn't just memory, is it? People, cognitive functions, I mean, we have to make sense of our social world, to be able to read intentions and feelings and emotions of others and our own self-awareness, and we have to make sense of our daily life. We have to plan on a day-to-day basis, meals, shopping, banking, all these kinds of things. So failures, I can remember in that first 10 years when, of our time here at Nodal, we'd formed some very close friends, and we kind of watched them through this period. And one in particular, was a victim of scams several times. And she was a very lovely person, and didn't think ill of anyone, and just a perfect sucker. for somebody knocking on the door, or in those days phoning, and saying, we've been looking at your bank account, and we'd like to help you out. All we need is the account number to do that. And I do remember at St. Mark's, how long ago, Virginia, but the Tuesday Tea people had the police squad out who dealt with all of this kind of stuff. And there were two of them came out, the room was dead. I mean, that was telling itself. I've never seen so many people come out to St. Mark's on a Tuesday afternoon as that afternoon. And then one of the policemen had several stories to tell. And then he would say, well, does anyone have, and all the hands would shoot up. So you knew this was really pretty prevalent. And yes, it is a real problem. Less interest in or ability to learn new skills, impaired speech beating. The speech isn't as rich as it was, with nuance. Yes?
When you're looking at that slide there,
Yeah.
and you're listing the things that we can't do if we've got memory problems. But you go back, I mean, it's not in the history of mankind, it's nothing, 50 years. I mean, people didn't have to remember passwords. They weren't on
PIN numbers.
computers. They didn't have iPhones. They weren't being texted. I mean, we have a much more complex world to operate in than my mother did. And which it demands a lot more mental acuity on our part.
Yeah, well, that brings up the whole business of social media competence. And ability to actually manage the digital world. Well, it falls off like a stone for most people beyond kind of the early 80s, mid-80s. I mean, and they're constantly getting in trouble with the stuff, and they have to ask their grandchildren or their children. Their children are less helpful, but their grandchildren, they're the ones who are all jammed up, or even better, the great-grandchildren. And they're really savvy. They kind of pick it up like that, and they don't forget. But for grandma or a great-granddad, can you write that out for me so I'll know in kind of a list? That's the difference, I think. So yes, you're right, Sheila. It is a more challenging world. But don't write off the real changes that are taking place here. They may be more obvious. I mean, I can imagine rural Ontario 50, 60 years ago in farming communities. Where would the pressure be? We weren't fussing too much about Tuesday or next Thursday or something like that. There was no television to watch. There probably wasn't a newspaper a lot of times, and no one was. And so the focus was on the church and farming. And that had the large seasonal calendar to it, but not the daily assault from CNN and MSNBC and all that kind of stuff. So you're right. Well, here's the pathology. Now, I put these up because those are plaques over there. They're Tangle's tau, think of tau, and beta amyloid plaques. I spent a most interesting year in Toronto after I finished my neurology training before I went to Oxford, working with a fellow by the name of Don Crapper of Crapper. Remember the toilet?
My classmate.
There you go. So Don was my supervisor, and he said because he had developed an aluminum model, aluminum salt model, and I couldn't believe it. I mean, every single cell in these cat spinal cords and in the brain were jammed with well, we didn't know it was tau then, but these neurofilaments, absolutely jammed. So my job was, because Jack Eccles had just got a Nobel Prize kind of a decade before for quite elegantly showing how one cell affected another cell and electronically and chemically. And so I thought, okay, we'll borrow that technique. I thought it was very elegant, it was at the single cell level, and I could not show any abnormality. I mean, these experiments went on for 24 hours, sometimes 36 hours. And I couldn't show anything. I think, how can cells be so jammed with stuff and behave functionally normally? And so Don and I looked at this stuff. We can't publish it. Who the hell wants to publish publish in their journal an article of negative results? Now I look back, and I think we should have, because function doesn't necessarily correlate with structure. That was the lesson I kind of took away from this. And there's another part of this. Remember I told you that cells fail at their distal extremities first? So I have cells in my the lower part of my spinal cord that are connected to my feet. So they have very, very long processes. When the cell body starts to go, it isn't at the cell body that goes, it's at the terminal end, and it kind of dies back from the periphery, okay? It's like having a long arm out here, here's the cell body, and it fails here, and then it moves up to the cell body. I was looking at the cell body. So that's why it probably worked. Anyway, we didn't know enough to do that. So let's carry on. Oh, wait a minute. Oh, yeah, here it is. Okay. This, I know it looks complicated, but stay with me on this. This is amyloid, the precursor protein. By the way, most of this stuff that goes wrong with neurodegenerative diseases is one protein or another. These are protein diseases, almost every single one of them. This happens to involve one that's named as amyloid precursor protein. Here's the cell membrane. That precursor protein is this thing right in here, and it's anchored by the part that mutates a lot. That's responsible for Alzheimer's disease, the yellow part. And if that kind of springs loose or is kicked loose from the cell membrane, it begins to break up in various stages to create the plaque. So the drug companies have come along and said, okay, here's a process we can understand, it's staged, so let's develop monoclonal antibodies and attack one or more of these stages. That's where the drug development has come from in the last 20 years. Okay, so there we are. There's an enzyme, a gamma beta secretase, which will actually break this bond and like this case, cleave it. And this normal chunk is kind of thrown away. And that was thought, gee, maybe we should use secretase inhibitor drugs to prevent this beta amyloid from getting loose. And it didn't work. In fact, people got really sick. That would be kind of 20 years ago. So anyway, so keep that in mind. Maybe not in detail, but that's actually a very good slide. Now there is a hypothesis. Science is full of working hypotheses, right? You make observations, and you look at the observations and you think, okay, what would be the best explanation for these observations? The observations in this case are that tau and beta amyloid accumulate in the brain. That's the basic hypothesis. So the hypothesis implies that the beta amyloid and the tau are what cause the damage. Or are they just the garbage, the byproduct of something else? And it's the something else actually causing the disease, and you're attacking the garbage. Follow what I'm saying? Okay, so that's where the basic hypothesis is in trouble right now. That's right. Yeah. So there it is. I don't have to read my own slide because I just said it. But anyway, we'll go on. And this is just that whole business that there is no time on here except that this is time to, this is the, when we would begin to think that grandma has a problem, and this period beforehand when certain other things are happening. And it goes back 2 or 3 decades. Now here's, this is a group of patients with the dominantly transmitted Alzheimer's disease. So they for sure have that. And then working back, and I'm not going to go through all of this, but if you look at a test of the mini mental examination, the score started to become abnormal 10 to 15 years before the clinical diagnosis was made. Okay? 10 to 15 year lag. The clinical dementia rating in sum of boxes, which is still used in the present studies, also goes back 15 years before. But if you look at deposition of beta amyloid in some areas of the brain, it goes back 25 years before. So the clinical tests of cognition certainly identify early changes, but it's not the earliest changes. Okay. Remember, the whole theme here is going back 20 or 30. This is a script that began 20 or 30 years before the play went on stage. All right, so that's very important. So if you were going to treat a disease, in this case here, ideally, don't start at time 0 or treat people who have manifest disease 5 years later. It's over by then. You're not going to change anything. You've got to go back here before cell damage started. That is the key. So just think about that. That's very important to grasp that. And no surprise. Now this is another way of putting it on a map. Maybe a little color to it. But look, here, this blue here is the A beta amyloid. So the earliest change is traceable back 17 to 20 years before clinical onset. But that's an assay. You have to be above a certain level before it's considered abnormal. So it actually is probably out here. Yes?
Is there not a blood test or something that could be done?
Well, there are blood tests now.
before
Yeah,
this?
there are bioassays on
No.
cerebral spinal fluid and blood. Blood isn't all that helpful, but certainly the spinal fluid is. But again, the abnormality has to rise above a certain threshold. And if you have a certain normal range, for some people it could be in that normal range, but it's still abnormal for them. Okay? We're getting into statistics now, but so clinical trials, this is getting to the meat here, last few minutes. Very expensive. It's not very good to have pharmaceutical companies involved in the design, management, and especially the analysis of clinical trials, and also writing the articles.
Yeah.
That's what Biogen was doing. That's why the controversy, just 2 or 3 years ago. They got heavily involved. 2 phase 3 trials that failed aducanumab, and Biogen said, oh, well, we've looked at the results a little more closely, and we think there's a special group here. We got up to a certain dose level, and the effect was there. And Biogen was very pushy. Now, they had billions of dollars invested in this. I get their point. But the FDA had a very good track record up to then. And of course, the hypothesis could be wrong. And aducanumab, I don't even have to bring this up because here's the drug that that created the controversy. Now, reasons drugs may fail to affect the clinical progression. Well, I mentioned it, I made the point early in the talk, comorbid conditions. If you have vascular factors, no drug, no monoclonal antibody is going to change that. So if that's in play as well, we're not going to change things. This is the biggest criticism of these tests by many physicians. The cognitive tests are just too insensitive to identify significant changes. Or the treatment began too late. Fair enough, the early studies, that was perfectly true. And these drugs are anti-amyloid drugs, but what about tau? So you're leaving out the second player. So here was a really strange series in the New England Journal of Medicine. This was all messily played out in their in one issue of the pros and cons. Literally, people, a little boxing match about, okay, what was fair, what wasn't fair, what was properly done, what was properly done, and I tell you, there was a lot of dirt on several players. Not outright deceit, but willful thinking, certainly, and driven by investment. And here are the three that are approved. Lecanemab has yet to be approved in Canada. Now, one of the interesting things that's happening right now, because of the questionable benefits of these drugs, and because of the high cost of these drugs, increasingly governments are saying, okay, we approve the drug, but we're not going to fund it. So that's what's happened in the UK. The UK, the National Institute of Health and Care Excellence, what a terrible thing, with an acronym of NICE, recommended against cost coverage. That's the new government. Well, what are they staring at? They're staring at an aging population that represents maybe 20% of the population now, but soon to be 30% of the population higher. And probably the true cost is $100,000 a year. Wow. For something that you're uncertain, or where you delay the stuff, but you kind of delayed the plague coming on, but it's still going to play out. You haven't stopped that. And hence, is that an interesting thing? So it really comes down to pressure on governments about whether they're actually going to fund it. Because who among us can come up with $100,000 a year for 15 years or 20 years? I can assure you that most health private plans won't, unless you're a civil servant. So somebody reminded me the other day. The Nanomab, there's Eli Lilly, good, and there's Biogen with aducanumab. So just a quick look about, and of course not all monoclonal antibody treatments work in Alzheimer's disease. Well, where the controversies, is the hypothesis correct? If not, what alternative hypotheses are there? Well, not many. How effective are the drugs? Questionable. What are the risks of the drugs? Well, I haven't even begun to mention that, because if you treat somebody in the asymptomatic period for 15 or 20 years, or even 10 years before, there's substantial risk, because many of these patients develop little bleeds, sometimes bigger bleeds, and even atrophy of the brain as a consequence of the drug. And that's when you're functioning well. So I don't think I would want to do that. And then, of course, who pays? And then I'll just come through at the end here. So what are people, where's the future in all this? Raisa Sperling is a bit of a hero of mine. She was, she just won, or a couple of years ago, the Lifetime Achievement Award, International Alzheimer's, back in 22. And she's had led the charge in the US for the development of almost all of these drugs. She's from Harvard, has an interesting team, and that kind of thing. If she'd been more successful, she would have a Nobel by now, for sure. Very, very nice person. And, but she, you know, this is the thing. Where are we going here? Cognitive impairment, believe it or not, correlates not so much with beta amyloid, but tau. So if you're not treating the tau, you're probably not doing a lot for cognitive impairment. So the way forward might be some of our great successes in medicine have come from, our greatest successes have come from combining treatments. So TB, I remember when I was working at a TB SAN one time and people were on 3 drugs. HIV, undoubted triumph for millions. Triple therapy, quadruple therapy sometimes. Each at a lower dose, but complementing one another. It's a good way to go. So why not combine a monoclonal antibody against tau at a low dose and against amyloid at a lower than standard dose and start that early? That makes a lot of sense. That's what's happening. That's what people are doing now. And I mentioned the price. So, well, I won't get into that. That's the message for today that I wanted to get across, that I couldn't get across because it's part of one of the talks of the aging thing. But I thought we should deal with this, and then I could try to put the data together for you so you can kind of make some sense of it, because this is coming up. You know, our provincial government, federal government haven't approved any of these drugs. They're approved in the United States because of a lot of lobbying from patients, patient organizations, the Alzheimer's Association, can't blame them. And then there's this great ethical question. You know, there's some treatments. Science has developed some incredibly targeted treatments that are very effective for genetic diseases, where you can tailor make, you can gene edit the thing out of something, but they're incredibly expensive because they're one of a kind. Each case is a problem to be solved. That is incredibly expensive. To investigate that kind of stuff with large grants, that kind of thing, that's one thing. But fortunately, those kind of cases aren't common. But this is common. This is the fate of living longer for many people. And if it's $100,000 a year, that's not the cost of the drug. The drug is maybe $25,000 to $30,000, but you can't have it unless there are continuing tests, including PET scans, and all this kind of stuff. You add up, that's why clinical trials in this disease easily cost $1 billion. Easily. So it's very expensive for pharmaceutical companies. They obviously, I get it, they want some return, or they're not going to continue to invest their effort. And but at the same time, how do you pay for that? And let's face it, everyone in this room here collectively represents 80% of healthcare costs, or will. And so at a time when, and I think governments privately sometimes look at this as, and it obviously came out from the UK, we don't have the money to support the requirements or demands of our aging population. We just don't have the money and resources. And so what do you do? It's an ethical issue, it is. But, you know, if you're taking money from Peter to pay Paul, what does Peter lose? And so where does that money come from? Where do you equitably get that? So those are all important questions which I seldom hear talked about. And when I go back to that physician from Toronto, the memory clinic, she doesn't even mention that. But that's clearly a thing. I mean, everyone's entitled to be an advocate. She's an advocate, and a very effective advocate. And thank goodness she's there advocating for the people that she's looking after. But that isn't who should necessarily be making the decision. I don't think. So that's my take on it. Now, any added thoughts? Because we're all part of this. It's not just me, you, and we're all part of this. Yeah.
I was taught that Lewy body dementia was only diagnosable post-mortem or pathology diagnosis. Is that true, still true?
It is.
Okay.
Yeah.
So you can't do anything about that? You can't prove it?
No, and we know a lot less about the protein that causes it.
Yeah. The other thing is Sharon Cohen. Do you know Sharon Cohen? Because there is a Sharon Cohen who is the daughter of our plastic surgeon in St. Catherine's, Dr. Richard Cohen. But I don't know whether that's relevant or not. No?
Doesn't ring a bell to
You don't know?
me. Yeah.
Okay.
I do know that in previous talks like this, the Alzheimer's Association gets sometimes stood up. But again, they're an advocacy group.
Mhm.
And guess who shows up to vote in election time?
Yeah.
And they're also conservative voters by and large. So anything else? No? Okay, James.
I'm not sure if I remember that there were a couple of NAN studies, but I thought one of them showed that maybe they had plaque, maybe amyloid plaque, but that there was no clinical manifestation. In other words, this function structure distinction was really clear in them, that they were still functioning at a very high level, but when they looked at their brains post-mortem, they couldn't believe how much plaque was there, and that it should have clinically shown that there was functional impairment. I'm just wondering if I remember the study correctly, and whether you remember it or anybody else.
I remember reading about it. It was done.
They were.
Yeah.
Yeah, well, they're great groups, aren't they? Same sex
Yeah.
and a captive group.
Yeah.
Yeah, so
And
there's.
same environment.
Yeah,
all that,
yeah. I mean, the nurses study in the U.S. is one of the largest
Right.
groups, yeah. And
But wasn't the implication of the study that somehow whatever it was they were doing found a workaround in their brain to, mitigate the problem that the plaque would ordinarily cause functionally, clinically?
one of the problems, if you just focus on beta amyloid, is just correlating. And by the way, all of these drugs do really well at clearing out amyloid. I mean, very impressively so. The whole issue is whether they significantly affect the clinical course of the disease in a meaningful way. I'm not talking about somebody coming in and doing a bunch of tests on them and claiming that statistically this is a meaningful result. I'm talking about actually a meaningful result for the patient and something that would be noticeable to the family. That's the issue. That's really the issue. So my reading of the data is that it's one of those traps science gets into. One time, if you follow back this amyloid hypothesis, I mean, it actually goes back to Don Crapper and Bill Brown days, way back. I mean, when people were thinking about this, they were certainly aware of amyloid and tau back there, or something like it.
He was very disappointed.
Yeah,
you know, it was just amyloid and
Yeah.
this stuff about the water and all this
Yeah.
sort of thing, and it was, that's
The other thing about
about
amyloid,
20 years ago, isn't it?
yeah, the other thing about amyloid, it collects in blood vessels.
Yeah.
And so another form of amyloid disease is amyloid angiopathy.
Oh,
And a very good friend of a good friend of mine in town here, the friend lived in Eastern Ontario, where was it? I think Kingston, anyway. And this person had a history of kind of little stroke-like things that had kind of come and go. And the MRI actually showed some of these vessels just lit up like a candle with amyloid. And that's one of the reasons maybe for the microbleeding. You put them on a drug and it takes out a protein that's partly is stabilizing the vessel and makes it more fragile and might explain why the bleeding, kind of one of those unintended consequences. So anyway, it is science sometimes gets stuck or gets stuck on one play and heavily invested in it, and then very stubborn to kind of change, and particularly if you've invested a lot of money. And so this is not an easy game at all. So to get back to one of the original things that we started talking about this afternoon, what is aging, what is disease? I think on the continuum, what we call Alzheimer's disease is part of that continuing stuff. And if we looked at mitochondria with the same detail, and we've certainly done that with DNA, there's an accumulation of mutations. Some of them are more likely than others. Some are more likely to be consequential mutations. Is that a disease? I don't think so. I think it's an old car and stuff's starting to go wrong with the car. If it isn't the brakes, it's the transmission, or it's this or that. But nothing that's been created by man holds together perfectly, unless it, you know, I have friends who are aviation buffs who restore, or at least they're pilots, and they have enough money to restore things like Spitfires or that kind of thing, and it costs them, you know, several $1 million to do that, and that to maintain them. But that's an example of stuff wears out and breaks down. And why would we expect any biological system to differ? After all, we speak of life, inanimate and animate, and we're the animate. But at the Nobel series is coming up, the 2 Nobel Prizes in physics and chemistry are the lie to that. It is clearly obvious they're one and the same. Chemistry taken to its most basic level is physics. It's atomic and subatomic physics. And whether it's animate or inanimate. And only when it becomes more complex does it reach the level of what we would begin to apply a term of life to. So I think, so in that physical systems, and certainly molecules break up. So in the grand scheme of the universe, what's going to be left when the universe implodes at some point? Well, none of the particles, none of the forces. It would be energy. That would probably be it in some form, and another Big Bang. But the point is, all of these things have a life, an interim, and an ending. And Harari, do you know the author, the Jewish author? And yeah, and Peter Castle put me onto a new book of his. And he does this so marvelously in telling personal stories, but always links it to the big picture, the long picture, going millions of years ago. And projected into the future. That's his strength as a writer. I think he should get a Nobel Prize in literature, actually, because it's an art form, be able to tell that story. And better than most creation stories that we have. Yeah.
I'm just wondering, when talking about stage 1, stage 2, and stage 3 of clinical trials, you sort of wonder how, if you pass 1 and 2, you fail 3.
Well, one is to see if the drug, I'm simplifying here. One is to find out, is the drug even tolerable, or people get really sick, or is it toxic? That's the first one. Then the second one is, if it passes that level, the phase 2 is, well, does it have any effect at all? That's when the trial includes different doses of the medication. And that's where Biogen kind of came in with aducanumab, because they said, well, it was only when we got to the highest dose that we think it had an impact on cognition. And maybe they were right, but 2 phase 3 trials didn't show it. And then phase 3 are the things that really cost some money is phase 3. It's very hard to recruit patients. You can imagine if you were doing a trial in Alzheimer's disease, you would have to follow me for 30 years, 20 years at least. We're mobile, we move around, we die. Other things happen to us. I mean, how are we going to carry out a long trial life? That's why the poor mice and rats are the common models, because they don't last long. But are they us? Well, they're not, because genetically they're very pure. We have a lot of genetic diversity. They don't. And the lab people don't want them to have genetic diversity. They want them to be the same.
Do we have 3 stages in Canada for testing?
Sorry?
Do we have the 3 stages, 3 levels of clinical testing in
Yes.
Canada?
Yeah,
Do we have to follow the same procedures?
Yeah. Oh, now, that's another interesting point. These drug trials are so expensive. It used to be, say with vaccines, every country would carry out their own trial. We saw some of that with COVID, didn't we?
Yeah.
We had Oxford University developing their thing. And we had another product in Europe. And then the FDA got involved and developed another, anyway, several people. They are so expensive that there's no way, for example, with the new COVID drug, that Canada is ever going to even consider replicating those clinical trials. Why would they do that? And England didn't do it. They went straight to the American trials and said, okay, they did a good trial. We accept it. But we're not going to plow millions and millions of dollars into a made in England trial. Those days are over for drugs like this, which is too bad, because in a way, having multiple sources is a check on things, but it's just become very, very expensive now. And so
one of the problems happened when Mr. Harper sold Connaught,
yeah,
our Connaught Laboratories.
yeah.
All right?
Yes, I agree with that. I do agree with that. And it was interesting. I mean, through COVID, I mean, did we suffer because of that? No, because the pharmaceutical companies were actually very good at what they did. But as you well know from last year or the year before's Nobel Prize for mRNA vaccines, we were really lucky that the technology was on the shelf.
Yeah.
It did not have to be created. It just took it
Tac-Mac?
off the shelf and very quickly developed a vaccine.
Wasn't it Tac-Mac?
Yeah.
Yeah.
Yeah, I mean, normally, if you look at the development of vaccines, that period can be 5 to 10 years, starting from scratch. But fortunately, that's technology we might not be so lucky the next time. Yeah, so very good. So anything else? wasn't.
Could you just explain that last sentence? Why do these proxies make such a difference?
Oh, okay. Okay, I wasn't going to talk about this, but anyway, patients with healthcare funds, we have an understanding of the prognosis and clinic, of course, are likely to receive less aggressive care. The default setting in some institutions is to keep them going, whatever thing. Sometimes, you know, I know that Jan, if in her sound mind, and until maybe 3 years ago, even though quite diminished, still felt that as she felt when she had it all together, that she did not want to be going on past recognition of family and friends and meaningful social interaction. She did not. And most of us have written up something like that but you know, once somebody's in an institution, it becomes trickier. And it's even trickier now because Pleasant Manor radiant care, say 4 or 5 years ago, was everyone, I'm exaggerating, but everyone was Mennonite. The staff were Mennonite, the residents were Mennonite. Same book, same beliefs, same culture, everything, everyone understood they were on the same thing. Now, 2/3 of the staff are South Asian. Nothing wrong with that. I can tell you just from observing the care that they provide, very good. Just as good as the Mennonites who preceded it. But it's more complicated when it comes to dealing with the patients because, you know, the natural way people, you want to know what happens to people at the end with dementia, the most common reason for death is that people can no longer swallow properly. So they aspirate. And they have 2 or 3 bouts of pneumonia. They kind of get past that, and then they get a really bad one, and that's it. Now, I think nature has natural exit ramps. That's a common exit ramp. It's been nature's way for however long we've been around. But medicine kind of got in the way in the mid-last century because of ventilators and because of a very can-do-ish attitude. If you can keep somebody going, keep them going. And no one questioned all this stuff. But now, or people would, there was a middle period in there where wise physicians kind of handled that really well on the quiet, without, just one-on-one. I do remember, I think I've shared with this, but when I was taking out a girl in a small town near Brantford, and her father was a GP, and I was in pre-med, it wasn't even in medicine. And he would take me around on rounds. He had a little black bag, you know, torn, that kind of, all of his patients were farmers. And I remember he was a delightful man. He knew his patients, and they knew him. Talk about sheep knowing their sheep, or their shepherd, and the shepherd knowing their sheep. There was the example. So when things got bad, and they often got really bad in those days, things that we don't see ever now, but the huge cancers eroding through the skin or falling through the rectum or the vagina, or I mean, awful stuff. And smelling, and you know, nothing to be done about it. And I do remember on at least 3 occasions, they understood. So when the time came, the family was there, all the members of the family, friends, and they all understood what was going on, including the person. And no one ever said anything, we are going to kill you. This is not made with a kind of formal kind of thing. It was probably phrased sometimes, this will make you more comfortable, which of course it did. And it was morphine or benzodiazepine or a combination of the two. And the person kind of quietly went away. No one thought the worst of it. The church didn't think anything about it. Service went ahead. No one. It was the way it was.
And the patient wished it.
And the way the patient wished it. Yeah, that's right. Now we're in this tangle with MAID. And I mean, I've witnessed that, or not, yeah, I suppose I was part of it this year. And once, and however good the person, and the person, the example I'm thinking about was incredibly good, it becomes formalized and awkward. And so what was very easy for the patient and the family has become kind of almost a government process. And I know not all of you will agree with me on this, but I do think my clinical ancestors were better at this, but they were allowed to be. No one ever challenged it that I remember, ever. And I certainly remember Charlie, ex-Canadian people, after talking with the family and explaining everything, and everyone was on board. And so it gets to, we've almost made death kind of a huge thing.
Optional.
It's kind of an optional thing, as if it's kind of a standalone kind of thing. Isn't there a process here in life? Beginnings, middle parts, and it has an end. I mean, whatever did we have in mind that this is going to go on to 130 or to 150? What did we think people were going to die of? Sheila?
Yeah, I mean, I had a very different experience because my husband had Alzheimer's, and it got to the stage where, you know, he'd only be kept alive by having a stomach pump or whatever medical term is. And I said, no, and the nurse asked me and said, would you like a stomach pump inserted? I said, no. And that was it.
Yeah.
Nobody asked. I said, I want him brought back. The hospital was still going in his last days here in Narragansett Lake. I want him brought back to the hospital. That I didn't have to produce anything. They did exactly that and let him die.
I
I
think it's
thought that
right.
was terrific.
I think it's right.
Yeah.
That's
You know, I mean, nobody got excited. It was just done. It was done, and you know.
that restores a dignity to
Absolutely.
what should be a natural process.
You can have a DNR, but that has to, for the person to have foresight, to sign a do not resuscitate order.
But as you
Otherwise,
know,
the staff feel obliged
yeah,
to go through the maneuvers.
And it is terrible.
yeah.
But why does it have to be for something physical? Why can't we, well, we're still sound of mind saying, when I get to this point where I don't recognize, I want to go, I would like to have made.
This is the future.
I don't think that's
Well,
really
we came
wrong.
very close to that, didn't we, this,
Yeah.
the last year with dementia?
Yeah.
Because I wrote a couple of articles about that, really to say what Jan would have said. And the issue there is, or was, okay, you've got this document, but like as with MAID, you have to consent right up to the end.
But you
Yeah.
can't.
No, I know that, but in the case, Parliament almost approved that,
Yeah.
meaning you could, there would be one level that you would sign off on when you were cognitively capable of doing it, and provided you framed the threshold in a way that worked practically, that would be binding. When you reach that threshold, MAID would proceed. But the Liberals are minority, and I'm sure it'll come back. It needs to come back. My heavens, we're a lot better handling our pets than our family. Why do we treat our pets much
Better
better?
than either of us, so, yeah.
I don't get it. I think, well, anyway, so I think we're on our way. Yes, you could, no. Did you have anything to say, Susan? No?
I'm actually going to be silent for a moment.
Oh, you're, okay. Okay, I'll take that moment to leave.
I would.
Thank you.
Okay, well, it's good discussion. Actually, this whole issue, this last issue would be worth actually a discussion.
Yes.
Yeah.
Thank you.